And let's share. Okay, so yeah, no, I'm not teaching 3004. Next year I do this class again, which I'm kind of happy about. And I do 2804. But this class I really, because there's a lot of things that I kind of want to make changes to, so I'm happy they're giving me this one again. But yeah. Okay, sorry. I'm a little whacked out on, on pain meds. So apologies if I lose my train of thought here or there. Okay, so we're here on March 23rd. We are going to continue our lecture on operator overloading. As far as tutorial 8 and 9, of course, our tutorial 8 is due this weekend. Tutorial 9 is due next weekend, along with assignment 4. Just a little heads up, because I think a lot of people have been stuck on, I did mention it in Discord, but a lot of people have been stuck on the idea that since we are using inheritance and we're using polymorphism, you have to have those virtual destructors in your parts classes, all of them, and they could be empty, that's fine, but they have to be there. It's just one of C++'s little quirks. But yeah, I think that, what else did I want? Oh yeah, I'm gonna post some assignment 4 output. I think that's it. Any questions on the schedule? Yeah, 3 weeks left. It's pretty crazy. All right, if there's no questions, I will jump back in. So yeah, I'm having a little problem with my wisdom teeth. I'm gonna get taken care of this summer, but in the meantime, I will reschedule my office hours for Friday, as long as everything goes well. Sorry I missed them yesterday, and but yeah, everything's fine, but I am a little high on meds right now. Yeah, so if we get 100% on all the tutorials, we get the 1.5 bonus without doing tutorial 10. Yeah, that's probably fair.
My reasoning is that we're allowed to drop one tutorial, but if we have none as the lowest one to drop, could we not use the quote unquote dropped one instead and save us a little bit of time?
Yeah, I'll consider. Still the exact breakdown of the marks. There's a little bit of wiggle room there. So yeah, I'll definitely consider doing something like that. I just want tutorial 10 to be worth maybe a little bit more, but we'll see what happens. All right, any other questions? Okay, so last class we left off, we were talking about operator overloading, and we had gotten as far as the rule of 3. So we were talking about implicit and explicitly overloaded operators. So you do get some for free. And in particular, or one of the ones that you do want to pay attention to is the assignment operator, right? So the assignment operator, you get one for free. It behaves similar to the default copy constructor in that it will do a shallow copy of, all of the member variables from one object to another. So if I said something like Joe equals Matt, then all of Matt's member variables get copied into Joe. If there's any dynamic memory in my student class, then I probably want to overload that, which is, the rule of 3 is essentially if I have these dynamic memory requirements, then I probably will likely have to override or overload the copy constructor, the destructor, and the assignment operator. And then also, we did talk briefly about move constructors and move assignment operators. They will not be part of this class, but they are part of modern C++, and that's essentially when you want to do the opposite of a deep copy, you want to do a shallow copy again. So yeah, because I'm moving an object from one place to another rather than copying it. So that's where we left off last class. So yeah, overloading operators. So each operator is actually a function. So we saw a bunch of examples of that with the time class. It's the keyword operator followed by the operator symbol, and they are predefined in the language. So you have a set number of them. You can't introduce new ones. But the nice thing about it is that I can define a function operator double equals, and then when the compiler is searching through your code, it uses this. It can look for this format instead of this format. So that's a neat little feature of the language. And basically what happens is the left-hand side operand, in this case, is my name. That would be the object that the operator function is being called on. And the right-hand side operand would be the parameter. And that's for member functions. So and each of these operators comes with, a predefined set of parameters. So for the double equals, there can only be one parameter here if it is a member function. So operators can be overloaded as member functions, which we just talked about quite a bit, but also as global functions. Of course, you can't do both. So what happens is that I can overload, right? My name equals your name. I can choose to overload this as a global function, but of course, when the compiler reads this, if I have both a global and a member function, it's not going to know which one to choose. And I think it chooses by default the global. So then your member function becomes useless. It'll warn you a bunch, but at least this version of the compiler that's in the VM does not throw an error, or at least I have not been able to get it to throw an error. Some of the limitations on operator overloading, you cannot change operators for primitives. So 2 + 2 has already been overloaded by the compiler. And, if I declare an int, I say a + 2, that's the same thing. I cannot overload that plus operation for ints or doubles or what have you. You cannot create new operators. So we have a set number of them, and that's it. Those are the ones you get. You cannot change any details about the operators, such as the arity, right? So this plus operator is a binary operator. It's a binary function, which means it takes 2 operands, right? So I have one here and one here. You cannot make that into 3. I cannot have 2 + 2, 3 or something like that. You cannot change precedence or associativity, right? So the plus operator, if I write something like this, then this gets evaluated first, and then the result of that is 4, and then this gets evaluated next, and then the result of that is 7, and then this gets evaluated. You cannot change that order, right? That's what you get. Likewise, if I throw in a multiplication operator, then the compiler will do this operation first, and then this operation, and then take this result and add 4 to it. You cannot change that either. So if you overload the plus in the multiplication, be prepared for this sort of bedmiss order of operations. Some operators cannot be overloaded. The scope resolution operator. So that's, this guy, the conditional operator, which is this guy, and a few more. Incidentally, you can overload the arrow operator, which is interesting. We're not going to do that. But yeah, you can. Yeah, I don't know. I would have to be very careful doing that. Okay, so in terms of time to swap the plus and the multiplication, yes. That would be quite funny. We should enable cascading where possible. So what does that mean? Well, we saw some examples with the plus. So if we do this, we should return something sensible, so that if I want to have 3 operations, or I define a bigger expression, that this will make sense. So this will return 7. And this 7 I can apply to this plus operation. So, and we should be able to do that also with, if we had a bunch of student objects, we should enable this sort of cascading if we're going to overload the plus operator, right? And then, of course, the assignment operator in this case, well, this will assign the value 0 to D, and then it will return the value of D, and then that value of D gets assigned to C, and then we return the value of C, etc. So that is cascading, where we can combine, all of these functions into a single expression. So yeah, so when we're defining these operators, we're not going to be using output parameters. Okay, we're going to be using return values, because return values are the only way to get this to work. So return parameter probably should be value. And the general rule for cascading is that you should implement it the same as it would apply to integers, right? So these here are ints, or if we assume that how long ago did I lose you guys? All right, sorry, I will be right back. I'm going to make sure I'm at home today. I'm going to make sure that nobody else is using the internet right now. Sorry about that.
All right, who wants to take over?
Okay, sorry about that. Hopefully it stays up a little better. Let me see. We're recording. I'm just going to share. All right, it says my internet connection is unstable. So yeah, sorry about that. Hopefully sometime, I don't know. My internet goes up and down here. So hopefully it gets, it sorts itself out. But if I do go away, just wait a few minutes, I'll be back. If it becomes a major problem, I don't know. I will just finish recording and post a video, I guess. Okay. So yeah, I was talking about operator return types. I'm not sure when exactly this cut out, but yeah, we want to enable cascading the same as it would apply to integers, right? So any sort of operation that I could do with integers, such as this or such as this, if I overload those operators, then I probably want to enable the same sort of thing, with my student class, for instance. So, and in particular, what that means is that most of our overloaded operators should not return void. They should return something useful. All right. So to enable cascading, one of the tools that we use is the this keyword, right? So we get that for free. This is passed in implicitly as a parameter to all member functions of my object in my class, right? So yeah, we don't see it there, but it is passed in. As a side note, in Python, when we implement classes, we pass that in explicitly, right? Or at least the last version of Python I saw did. So if I wanted to send in the this keyword for Python, it's called self, and I explicitly put it as a function, a member parameter. Sorry. And then this is the this object for Python, but for C++ and for Java and languages like that, we get the this keyword that's passed implicitly. Of course, this does not include static functions because static functions have no object to operate on, so there is no this keyword for a static function. This is used implicitly or explicitly, right? If I have a name member variable, I can write name in my member function, or I can use the this keyword with the arrow operator. These are the same thing. We generally use this if there's some sort of collision, naming collision. Okay, so cascading is chaining together member functions in a single statement. How does it work? Our member function returns the left-hand side operand object, generally speaking. This is not always the case, but in this case, we will be using it. So using the this keyword. Yeah, and then the next member function operates on the returned object. So, we'll see an example here of cascading. Somebody asked me with quite a bit of alarm if you are expected to do that on the assignment to enable cascading. We'll say cascading is, you can do this, and I'll show you how, but you don't have to. Cascading is more for operators in terms of assignments, but I don't even think, I think the only operators I ask you to overload are the stream insertion and perhaps the less than, but I'd have to look that up. Okay. So this was the previous example. So here we have our time class again. And a few things have changed. So our set time, we've broken it down into set hours and set minutes and set seconds. So we're doing that individually so that we can, of course, demonstrate some of these concepts, but they all operate the same way that they used to in the set time. So our set time function now calls on set hours, set minutes, and set seconds. And these functions individually make sure that your input is something reasonable, right? So if it's not between 0 and 24, we just set it to 0. So what we want to have happen now is, so we're going to define two time objects, wake up and lunch. And we will, for now, just print them out. Make sure everything's working correctly. Where am I here? Yeah. It was right in front of my eyes. I didn't even see it. Okay, so wake up and lunch are both okay, so the subscript operator, perfect. Yeah, that's good. I should have put a less than in there, but next time. Okay, so yeah, we've printed both of these objects. They're both 0, so now we want to set our wake up to be, so we could say wake up dot set hours. So let's wake up at 5. And that will be fine. So we could do this, of course, but I want to be able to do this chaining. So set minutes to this, and then maybe set seconds to, let's say, 45 seconds. So in order to enable this, we have to return something sensible in our functions. So what we're going to do is return a time reference, right? So the same thing with return values. I'm not going to enforce it on the assignments, but the same thing, return values, the same principles apply to parameters, where we want to return by reference whenever possible. There are instances where we return by value. We do that deliberately, but of course we pay a penalty because it has to be copied. But yeah, so we're going to return a time reference, and the time object that we're going to return is, of course, this time object. So in our implementation now, yeah, we want to change the return values. And then, and then we want to return this. However, you can see the compiler is complaining because this is actually a pointer. So what we need to do to return the object is dereference it. Okay, and then we will apply this to these. Okay. Now our main function, now the compiler is no longer complaining, but let's make sure that it's still going to not complain here and make sure that it'll work. All right, so now our wake up time is 5:45 and 45 seconds. Lunch is still 0, but we've made these set functions, so we've enabled chaining in our set functions. All right, questions? Okay, we'll add a few more here. So this should probably also return a time reference. And then we can do other fancy stuff as well, such as all right, so then in our main function, we could do something like this, right? So maybe we want to set our lunch and print it at the same time. So set time 12:00. And then with chaining, we can print it at the same time. All right, so yeah, our wake up time 5:45, lunchtime 12 noon. And we can do all of that in one line. All right, questions? Okay, so this is, you can do this in your assignment if you like, but I will not be looking for it. This mostly applies to operator overloading and how we're going to implement it. Okay, so overloading operators as member functions. The left-hand side operand is the this object, right? So yeah, so if I have a binary operator such as the plus operator, so again, not to pick on Joe and Matt, but when I write this, I'm referring to Joe, and the argument that is passed in as a parameter is Matt. So whenever possible, we want to implement these operators as member functions. This is good software engineering. You know, you're practicing encapsulation and all of those things. Of course, this is C++, so that's not always possible. So sometimes we have to overload an operator as a global function. So when we overload operators as global functions, all of the operands are parameters. So if I have, for instance, you know, this I would write as something like this. Then my left-hand side operator operand is passed in explicitly as the first parameter, and my right-hand side operand is passed in explicitly as the second parameter. Now, in order to get this to work properly, we might want to make this global function a friend of the operand class, right? So this might be necessary in order to get the necessary access to the member variables. And essentially, this is, you know, the only permitted friendship, the use of friendship in this course. It's not, you know, not saying it's the only useful thing to do, but in this course, it is sometimes necessary. So by convention, the global function, if we write one, goes into the source file of our class, the class that it's supposed to be used for. So why do we have to do this? Well, sometimes an operator cannot be a member function because the left-hand side is not a class. right? So maybe I want to be able to, instead of comparing my student S2 to another student, maybe I want to compare them to a number, if that makes sense. Or maybe what actually might make more sense is comparing them to a string. So I might ask, is Joe equal to this student? And that might be something that we want to implement. However, this is a string, and we cannot add a member function to the string class because that's not our class. So what we have to do is, make a global function and then give it all the necessary permissions. All right, P4. Okay, so let me get my cheat sheet set up. All right, so we have a double equals operator implemented for our time class. And here we can define, a time object, and then we're going to define other, a lunchtime and a breakfast time as integers. So in these integers are the number of seconds, if I, going back here, if I use this convert to seconds, of course, I multiply the number of hours by 3,600 and the number of minutes by 60. And then I add in the number of seconds, and that is the total number of seconds since midnight of the previous day, let's say. So we can represent our time objects as integers in that sense. And so it would make sense to want to compare them to an integer. So we want to be able to say stuff like, is wake up equal to lunchtime? Well, lunchtime, this should be, this is 12 noon. Our breakfast should be equal to our wake up time. It's 20,700 seconds, but we want this operator to work. So what we're going to do is, this is the left-hand side operand is the time object, so we can make it a member function. The right-hand side operand is a integer. So we want to add another function. We're going to overload this operator yet again, but now with an integer. All right, and then t, and then we will return, well, it's quite simply, we have the convert to seconds, and we can reuse the integer double equals operator to see if they're equal. Okay, so now in our main function, this is no longer, the compiler is no longer complaining. So is wake up equal to lunch? Let's see. So is wake up equal to lunch? No, which is correct. And also now we can compare this, time object to an integer object. Yeah, this one will actually also work. Is wake up equal to breakfast? So yeah, wake up is not equal to lunch, but when we wake up, we do want to have breakfast. That is true. All right, of course, we also want to be able to reverse these things, right? It makes sense that if I can compare a time object to an int, I can also do an int compared to a time object. However, now I don't have access to this int class. So what I have to do is make it a global function, and I'm going to make it a friend so that I can access the hours, minutes, seconds, and convert to seconds if necessary. So operator double equals. Now the left-hand side operand, we want to be an int. The right-hand side operand, we want to be a time reference. And to use good software engineering, we should also make it a const. Here, I don't mind making, and I need a return value or a return type. Here we don't mind making a copy of the int, of course, because it's a primitive. It's very small, smaller than even a pointer or a memory address. But here, of course, we want to pass by reference, and a const reference is safer. There's actually a problem. Actually, I'll leave it off for now, and we'll see this problem when it arises. Oh, no, that comes later. Never mind. We'll leave it here for now. Another example down the road has this problem. Okay, so we've, in some sense, told the compiler, hey, there exists this function, and we want it to be a friend of this class. Now, by convention, we put this function in the time.cc file. So this will be bool. It's not a member function, so we do not need the scope resolution operator. Int I const. This should actually also be const. Let's do this properly. Oh no, sorry. What am I talking about? You can't make a global function const. It makes no sense. Right, never mind. All right, so if it was a member function, we'd want it to be const. So now, yeah, t.convert to seconds. I simply reuse this double equals operator for ints, and then we return that. All right, and let's make sure that that works. So the compiler is no longer complaining because you can see that there is a function, but let's make sure everything's working. Okay, so is lunch equal to wake up? No. Is breakfast equal to wake up? Yes. So our overloaded global function is working properly. All right. Questions? And this is incidentally how we overload the stream operator too, which you guys will be doing, but that comes next. So yeah, that's all those examples. Okay, so some operators, of course, can be overloaded as member functions, right? The typecast, the subscript, the arrow, or sorry, only overloaded as member functions. We cannot do these as global functions. And of course, if we overload them, we should always enable cascading where appropriate. Some operators can only be overloaded as global functions. So, and in particular, what's relevant for our assignment is the stream insertion and stream extraction operators. Not so much the stream insertion, but and other operators for commutativity, right? So in the example we just saw, if we overload double equals for time and int, it makes sense that both of these should work. And of course, we always want to enable cascading where appropriate. These are Boolean, but for our stream insertion and extraction operators, we've seen stuff where we do, A, B. Well, these are two different operations, and this is because we've enabled cascading, or whoever wrote these has enabled cascading. So we want to make sure to do the same thing. All right, so stream operators are already overloaded for primitives, and they must be overloaded as global functions because we don't have the left-hand side, we don't have access to the stream object members. We can't make a new member function. And then we want to enable cascading, so we want to return a stream object. So what happens when we write something like this? If the time is a time object, well, the compiler first looks, in the OStream class for this function, and in particular, this operator function with the time class. Of course, we wrote the time class, so there is no such function in the OStream class. So the next thing the compiler does is look for a global function. Okay. All right, so again, our good old time class, we still have a print function, but now we want to, instead of using print, we want to overload the stream insertion operator. So in our main function, we have a time, and then we're going to output it to the output stream. So we want this to work. So two things we want to have happen. We want to be able to put a time. We want to be able to send a time object to this operator. And also we want to return whatever this output stream is so that these end lines will also work. All right, so we want to enable cascading and this operator at the same time. So what we're going to do again is make a friend function. What is it? So this returns an O stream reference, and then operator stream insertion. So the left-hand side operand is the first parameter, which is an O stream object. And then the right-hand side will be a time reference. So is it here? So this should be const. This should be const because we're simply printing it out. This is not where the problem comes in. The problem comes in a little bit later. However, I don't want to make this O stream a const because I'm actually making changes to this, right? I'm sending something in, and the O stream is going to print it to the screen. Yeah. Yes. So yeah, good question. So yeah, we do not want to make this const. We do not want to make this const either, because this and this operation is not const, even if we could do it as a member function, which we can't. Okay. So again, we're going to put the overloaded operator here. We want to return an O stream object. Takes an O stream object and a const time reference. Let's call this OST. Okay, and essentially we just want to mimic what's happening with the print here, right? We want basically this exact same thing. So we're going to copy it over and make a couple changes. This, instead of cout, will be OST. Of course, these are now member functions of this T object. So we're going to, since it is a friend function, we have access to these private members. So yeah, it's, you know, arguably a weakness of the language that we have to, there should be a way to make this a member function, but there isn't. So we have to use these workarounds in C++. But yeah, if we look back at our main, this is fine so far. We might run into trouble here because I forgot to return OST. Okay. So yeah, everything should work now. So the current time is 16:40:56, which is what we wanted to have printed. And yeah, it looks like that's working fine. The global stream, yeah. It has, yes, because we made it a friend. If we did not make it a friend, we could still have that. We just wouldn't be able to access those private member variables. There are ways around that, right? For instance, we could have, I don't want to necessarily get into this. We'll see the way around this later when we get into how we can implement polymorphism on this output stream. All right. Yeah, any other questions? Oh, yeah. So that, yeah, that comes a little bit later in the, because you can, you know, oh, we'll show you how to do it. All right. So the other one we want to have work is, this is from an actually older example. So we want this stream extraction operator. So we want to be able to say, please enter a time. The user is going to enter a time as in hours, minutes, seconds, separated by colons. And then we want to have that put into our time object and then print it out. So we want this to work. So again, what we're going to do is make a friend function. Now this is going to be an input stream. We want the stream operator to go the other way. And that's, we're going to return an input stream. Okay, so then, let me copy that. Again, this goes in our CC file. You can get rid of this friend. So iStream and time, of course, we no longer want this const, right? Because we're going to be making changes to it. So we're, yeah, this, we do not want const. Okay, and then let me see here. So it's a little bit tricky to get the formatting, so I'm just going to copy it over. Or to, oh yeah, okay. So what happens? So we know the format we're expecting. We're expecting hours, minutes, seconds. So what we're going to do is we're going to make some temporary variables, hours, minutes, and seconds, to hold these values, and then we're going to read them in. So our input stream can send a number into a integer, but we're going to only take 2 digits of the input, and then we're going to send that into the hour. So that's the first thing. Then we want to ignore the next character. So we'll say ignore this throws away the colon. And then we want to do the same thing for minutes and seconds. So minutes, yeah, all right. And seconds. And we don't need this final ignore. Okay, so now that we have the hours, minutes, and seconds, we could say t.setTime hours, minutes, and seconds. And then return the input stream to enable cascading. Okay, so what should happen now? First of all, any questions on anything we've done here?
If somebody only entered 1 digit for the hour, would it ignore a different character, that next line? You know, if they only entered in, 1 digit for the hour or minutes or whatever.
Yeah.
Would that throw off the ignore of the colon?
That's a good question. Well, let's try it out. So yeah. Yeah, for sure. Okay, sorry. Our main now is going to ask us for a time. So first we'll do it correctly and see if it works. Please enter a time. Let's say 12, 55, 16 seconds. So the new time is 12:55, 16. So yeah, let's say 7, 55, and I'm so creative, 16. Yeah, it read that in. So I guess, so now I would have to look up, I'm not very good with these formatting things. But probably what's happening is that this means take at most 2 digits. But yeah. So so probably what's happening is that it's only taking numbers, and then once it finds at most 2 numbers, but maybe less, then it stops, and then we throw away the colon, and then it looks again for at most 2 numbers. But I think actually, because I also tried something like this with another class, this will still work. So it just looks through and finds, it stops when it reaches the colon, essentially. So enter a time, 13. So yeah, even though we set the width to 5. So what happened here? Why is that? S is undefined. Oh, because I did that. I see. So yeah, I'm trying to think of a way we could try and break that. I don't know. Yeah, I mean, it took those numbers in, but it just sanitized it when we did the set time. Yeah, you would have to, I'm not super knowledgeable about all the ins and outs of these formatting options. They are very useful, but you know, what are their limits? I'm not exactly sure. So I don't know. Hopefully that helps a little bit, but any other questions? Okay. Is that all we wanted to try? Yeah. So we can read in objects, we can output objects. All right, so the stream insertion operator takes 2 operands because it must be a global function, or sorry, stream insertion. So the left-hand side would be an OStream object. So typically it's cout, but there are other OStream objects. The right-hand side is the object to be output, also passed by reference. You do want to pass a const reference for the output stream. There can be problems if you don't. And if you wish to access private members, then you can make it a friend function of the class. The stream extraction operator takes 2 operands. The left-hand side operand is an iStream object, typically this cin. And the right-hand side is an object to be input, should be passed by reference. But in this case, of course, we're wanting to make changes to this right-hand side operand, so it should not be const. And also, if we have to, we can make it a friend function of our class. All right. A unary operator is overloaded as if a unary operator is overloaded as a global function, it takes 1 parameter, a reference to an operand, right? So a unary operator, an example would be the ++. So there's only 1 argument to this function. So if we overload it as a global function, then that 1 argument is the 1 single parameter. If it's overloaded as a member function, then there are no parameters. So we will see an example of that coming up. If a binary operator is overloaded as a global function, it takes 2 parameters, references to both operands. And if it's overloaded as a member function, it only takes the 1 parameter. This is sort of a little bit of review. So what is this example? Oh, yes. Okay. So what we're going to do here is I mean, I don't think my slide quite matches with this example. So what we're going to do in this example is we're going to sorry. Well, this will demonstrate a few things, but it doesn't quite match the slides. Anyway, we're going to overload these plus equals operator, and we're going to overload the plus operator and also the assignment operator. So typically if I have an int, let's say a, and I say int, let's declare it, int a equals 0, and then I say a is plus equal to 5, I can write C out a and I get 5. So this statement is equivalent to a equals a plus 5. And then if we write C out, a, we get 5. So we're going to overload this plus equals operator along with this plus operator and the assignment operator for this one. And we're going to see, of course, we want to enable things like cascading, except now the cascading is going to be a little bit complicated because, you know, for this a plus 5, I don't actually want to return the a object in this case, right? So if I write a plus 5 and a is equal to 0, then I should be able to still write this out, C out a, and get 0, right? This plus operation should not make any changes to my a object. However, it should still return a value so that I can enable cascading. So yeah, we're going to see a little bit how to take care of that. I'm thinking, I don't know, maybe I messed up these. I might have messed up these examples. It doesn't seem to match up with what I was talking about on the slides, but it's a good example anyway. Okay, so we have now a private set time function. So this is going to be, because we're overloading the equals operator, this will come in handy. So yeah. Oh, sorry. The other thing we want to do for our time object, well, let's take a look at the example. I don't need to show you explicitly everything. So we want to define a new time object lunch, and then we were going to say, we're going to add 80 seconds to lunch, essentially. So this is an int. This is my time object. We want to enable this operation, this plus equals. So this is going to actually make changes to my lunch object. Okay, so, and we want to enable cascading. So we're going to return a time reference. We're going to do the plus equals, and this will take the right-hand side operand as an int in this case. So we'll set an int parameter. Now this does make changes to the current class, so we will not make it const. And then here, we'll say int I. Okay, so we want to add I to the I seconds to our current time. So we're going to use some of our operators. We have a convert to seconds. So we'll say int time equals convert to seconds plus I. And then we can use our new private set time that takes an integer. So then, all right, so we've converted the time to the current time plus I seconds, and then we set the time to that, which, you know, here we can see what it does. So this is integer division, so it throws away the remainder. So the number of hours is the number of seconds divided by 3600, throwing away any fractions. This should actually be mod 24. Right, so mod 24 will give us a number between 0 and 23. Here we're going to take, once we take away all the hours, whatever is the remainder is the number of minutes and seconds. So to get the number of minutes, we divide by 60. And yeah, and then we take the number of minutes and seconds. We take the mod operator, so it divides it by 60 and then gives us the remainder for the number of seconds. Okay, so yeah. Lunch before, lunch after. No return statement, return, what did I do? Set time. Oh, did I not return? I forgot to return this. So nice of the compiler to notice that, actually. Okay, so lunch was 12 noon. When we add 80 seconds, we get 12:01 and 20 seconds. So yeah, that looks nice. The other thing we can do, since we've enabled chaining, is we can, instead of doing it there, we can do it here. So this is going to return the lunch object, although we probably have to use brackets here. So yeah, lunch after. So this makes changes to the lunch object and then returns that lunch object so that we can print it out. Oh, I did that down here. Well, there you go. Okay, so later lunch. Yes, this returns the updated lunch object, and this is the updated lunch object. All right. Any questions? What's the giveaway that tells us we enabled chaining? Yeah. So we're returning, for the most part, chaining is enabled by returning a reference. Yeah, it's returning this. Yeah, this is the enabled chaining, but to enable chaining, basically, we want to return something that makes sense. In this case, we're returning a reference to a time object. It happens to be this one. That's not always the case. Sometimes we return a copy. But yeah.
I've got another little question to add to that.
Yep.
So in the input, in the argument parameters, there's nothing really being chained with that. Like previously with some values that we edit, we can use the parameters as an out. None of that really applies to this, does it?
I'm sorry. Could you repeat that? I didn't quite follow.
Okay, yeah, it's kind of lengthy. So I understand what you're saying, that we return this or the reference to this.
Yeah.
But if we want to, in terms of operator overloading, is there ever a time when we would want to use the output parameter?
For chaining?
Maybe in general.
Maybe in general. I mean,
or am I just kind of
no,
going?
I mean, well, it's fine. I can't think of an instance, but I mean, these are simply functions. So you can put an output parameter if you like, but for chaining, that would, of course, you need the return value.
Okay.
Yeah, but yeah, there's nothing stopping us from making these output parameters.
Yeah. Okay.
Right. Yeah, that's I'm sorry, I'm just trying to think of a use case for that. So maybe I want to pass in another time object that also gets changed or something. I'm not sure.
I'm weird. You don't need to spend time on that.
No, I like these questions. It's good. It's good to be thinking about these things. Anyway, that's user. I do like these questions. So we don't need the overloaded stream insertion operator. Yeah, we did. I just didn't explicitly mention it, but it is overloaded. Yeah. It's also and a friend. Yep. All right. Other questions? Okay, we also want to have this to work. So we need an assignment operator and we want this plus function to work. And it should work the same way integers work, which means that if I said something like this, this should return something sensible that I can send to the cout, but it should not make any changes to these you go home time, right? I add 3700 to it and I return something, in this case, probably a time object, so that we can enable chaining properly. Because if I had, I would also want to have I would want to have this work for me as well. So yeah, we need to be able to add 2 time objects or add an int to a time object, and we need to enable chaining, so this should return probably a time object. Yeah, all right, so let's do that. We're going to see one of the problems that comes up with our OStream operator. See, so what I didn't do here is I didn't make this const, so we're going to see a problem. Okay, so we want to return a time object for our plus operator. What am I doing here? So we want to be able to add an integer to it, and perhaps another time object. We'll just do ints for now. So this is, for now, we will just do this. Yeah, so we're going to return, but instead of returning a reference to this, I don't want to do that, right? I want to return the current time plus some value, but I do not want to make changes to this time object. So I'm going to make a temporary variable and I'm going to return it. So we're going to return by value, which is a little bit inefficient, but in this case, it is the appropriate thing to do. And we can actually make this const. Yeah, all right. Operator plus int I const, because we're not making any changes to the current time object. So yeah, we'll make time temp temp dot set time to convert to seconds plus I. Right, so we're taking the current time, we're converting it to seconds, we're adding I to it, and then we are using that number to set our temporary time variable. All right, and then what we're going to do is return temp. So we're making this on the stack, we're returning it, but we're returning it by value. So what's going to happen is there's going to be the compiler will be able to handle this appropriately. If we return by reference, it would complain because I made this on the stack and that stack frame is getting popped off. So then I'm returning, that will eventually get overwritten by something. But since I'm making a copy of it, this will work just fine. Okay, so let's take a look at what we've done so far. So now we can see that there's a problem, and what is the problem precisely? Well, let's try compiling it and getting a few more details. Okay, so it says cannot bind a non-const L value reference of time to an R value of the type time. So when I return, the return value from this is an R value, which means it's a constant, which means I cannot make changes to it directly. I can assign it. This will call the assignment operator. But this object that gets returned by this is some temporary R value, which makes it a const, which means that this will not work because we did not put the const here. So in this case, const is important to make sure that this output stream operation works the way we want it to. All right, so now the compiler has stopped complaining. This might work just as written, simply because we get an assignment operator for free. But yeah, interesting. But let's get rid of that for now. Okay, so I go home before 13:15 and you go home before, well, we've added 3,700 seconds to 12 midnight, and the result is 01:01:40. And then, yeah, let's print that out again, but without the yeah, so you go home should be 12 midnight. The point being that when we use this plus operation, we did not change the original object. We returned some copy. All right. Questions on this so far? Yes, the free assignment operator. So if you think about it, just as a member-wise assignment. So it's going to, and we have no dynamic memory in our time object. So the free one we get will work. So let's say you go home 3,700 seconds after I go home. Yeah, that should work just fine. So 3,700 seconds is what? It's 1 hour and 1 minute and 40 seconds, which is exactly the difference here. Yeah, it's pretty cool. So if you don't have dynamic memory, the default assignment operator is going to do all the things you need it to do. It will enable chaining. You know, I could say I go home. The one thing it won't do, however, is this. Or will it? Did we enable that? Why do I feel like that should be complaining? So I get an implicit, well, that's strange. All right. So that didn't work the way we wanted it to, but I'm a little bit surprised that we did not get an error message because we're assigning an int value to this object. But let's overload that. So in this case, we want to assignment operator, we want to return a reference to the current object. So our built-in assignment operator works for time objects, but maybe we want to assign it a value of an int. And then int, of course, this cannot be const because we are making changes to this current object. So yeah, quite simply, we say set time to I, and then we want to return this object. Okay, so now in our example, what we've done is this is the assignment operator that we get for free. This is the one we just overloaded. So this should actually give us a time of 1 hour, 1 minute and 40 seconds. Yeah, so I go home after 1 minute, or sorry, 1 hour, 1 minute and 40 seconds, and you go home after 1 hour, 1 minute, 40 seconds. Yeah, and we enabled, you know, we enabled chaining, and yeah. All right. Questions? Okay. All right, so just to reiterate, yeah, we need to, for the plus equals operator, we need to return a reference to the changed time object. So this is where we use the dereference to this. So we make changes to the current time object and then we return it. The plus operator is different though. So we do not want to return the current object because we don't make any changes to it, but we do want to return a time object that is, the original time object plus a certain amount of time. So we make a new temporary object and return it by value in our plus operation function. Okay, so we don't want to return an int because, possibly we want to do something like this. We call time plus 80, and then we want to print it out. Well, we're not really using print anymore, but we could call some other function on it. You have to keep in mind this returns an R value, right? That means this is const. So yeah, that const stuff does come in handy for times like this. Okay. What do we got left? 8 minutes. So we'll start by looking at some operators on collection classes. So for collection classes, there's lots of stuff we can implement, such as the subscript operator. These we can, there might be a case made for, we could do plus equals 2 vectors, and then that would put them together, things like that. Or if I add together 2 vectors, that might be a concatenation operation, right? So whatever, if I had 2 vectors or 2 arrays or what have you. Double equals and not equals for comparing, those would definitely be useful. So we'll look at a couple of those. Okay. All right, so here we have a book class. The book class we've overloaded the stream insertion operator. Should make this const. But yeah, otherwise we have we're using some bad get title, get author. This should be constant. I mean, this sort of, I would say by default, return a constant string reference, but then let me think. Yeah, it should be a const string reference. Well, there might be use cases where actually this might come in handy. But yeah, we won't really talk about that today. But yeah, we have an assignment operator, so I've overloaded the book assignment operator, but it doesn't do anything special because I have no, sorry, I have no dynamic memory. So I just do a member-wise assignment. The title and the author. Oh yeah, it does do something because I keep my ID of the original book. So I can copy one book into another, but the ID will always stay the same. Oh yes, and then I have to have matching function signatures. Okay, so yeah, that's our book class. And we have this not equals operation, which just does a comparison. Where is it? Yeah, so I check to see if the titles are equal and the authors are equal. And if they're both not equal, so what is this? This returns true if they're not equal, if one is not equal. Yeah, so if either of these are not equal, then I return true. That's right. So that's why the OR operator's there. Okay. And then in my main function, I make 5 books. Then, yeah, we can simply. Yeah, and then we're going to define a book array. But for now, we'll just make these books, make sure everything works. So it shouldn't do anything, which, hey, let's print out 1 or 2 just for fun. Cout B1, B2. All right, so we've enabled chaining, so we can chain together these output functions and then print out 2 books. That is not, yeah, Dune by Frank Herbert, Ender's Game by Scott Orson Card. So that set width that we did here is really wide. I guess there must be 35. I think, did I do that? It's possible. It's possible I did that. Well, maybe so long and thanks for all the fish. It's possible I did that just to demonstrate something and then I forgot to reset it to whatever it's supposed to be. So let's set that to something a little more sensible, maybe 20. Okay, so that looks a little better. It should be 20 might be long enough. Okay, now what we're going to do is make a book array class, and I think we will save this for next class though. We're going to make a book array class and we're going to overload some of these operations, in particular the equals, the not equals, and I believe the assignment also. Yeah, and the subscript operator. But yeah, we'll end a little bit early today because there's really no point in starting this. We won't be able to finish. And my mouth is starting to hurt. So that's it for today. I can stick around to answer a few questions, but otherwise I will see you guys on Friday. Yep.
Had to find the unmute button.